Here we have a problem on quadratic equation. Okay, let's go to the question. If alpha and beta be the roots of x squared positive 7x positive 12 equals to 0, find the quadratic equation whose roots are alpha positive beta the whole square and alpha negative beta the whole square. Okay, here we have to find a quadratic equation for which we have the two roots. One root is alpha positive beta the whole square and the other one is alpha negative beta the whole square. Okay, whenever we have two roots of a quadratic equation, there is a formula to get the equation, that is x square negative sum of the roots. Let me write the stuff over here. Sum of the roots times x positive product of the roots equals to 0. Let me write it. Product of the roots equals to 0. So this is the formula we have to find a quadratic equation when two roots are given. Okay, here we know that the quadratic equation that we are going to find as two roots, alpha positive beta the whole square and alpha negative beta the whole square. Then we have x square negative. To get the sum of the roots, we have to add these two given stuff, that is alpha positive beta the whole square positive alpha negative beta the whole square. So this expression represents the sum of the roots times x. Then product of the roots means we have to multiply these two roots. So there is alpha positive beta the whole square times alpha negative beta the whole square equals to 0. Okay, now once I get the value of alpha positive beta the whole square and alpha negative beta the whole square, I'll be able to get the required quadratic equation. For that, let me consider the other information we have in the question, that is alpha and beta are the roots of the quadratic equation x square positive 7x positive 12 equals to 0. Okay, let me write the stuff over here. X square positive 7x positive 12 equals to 0. This quadratic equation we have the two roots alpha comma beta. Okay, now let me consider a quadratic equation in standard form, that is ax square positive bx positive c equals to 0. Okay, when we have a quadratic equation in this form, that is standard form, there is a formula to find sum of the two roots. That is, for example, for this quadratic equation, if alpha and beta are the roots, then the sum of the roots is given by alpha positive beta. So the formula is we have to take negative sign, then we have to take the coefficient of x, that is b. It has to be divided by the coefficient of x square a. So this is a formula to get sum of the roots of a quadratic equation which is written in standard form. And also there is a formula to get the product of the roots, that is alpha times beta equals to, we have to divide the constant term c by the coefficient of x square, that is a. So the same stuff I am going to apply for this quadratic equation to get the sum of the roots and product of the roots. So now to get the sum of the roots, that is alpha positive beta equals to, I have to take negative sign, then I have to consider the coefficient of x, that is 7, then negative 7 over the value of coefficient of x square is just 1, that is the value of a. So when I divide negative 7 by 1, I'm just getting negative 7. Now to get the product of the roots, I have to multiply alpha and beta. So the formula is c over a. C means a constant term 12 divided by the coefficient of x square, that is 1. We get 12. Okay, now I have the values for two stuff. One is alpha positive beta and the other one is alpha beta. So the value of alpha positive beta is negative 7. The value of alpha beta is 12. Using these two values, we have to find the value of this alpha positive beta the whole square and alpha negative beta the whole square. So for this one, we don't have any trouble because we know that alpha positive beta is equal to negative 7. We can plug in negative 7 for this alpha positive beta the whole square. Otherwise, we can find alpha positive beta the whole square here itself. That is, so we can plug in negative 7 for alpha positive beta, then we get negative 7 the whole square, then we get alpha positive beta the whole square equals to 49. Okay, now in these two roots, I got one of the roots, that is alpha positive beta the whole square. Its value is 49. So still I need to get the value of this alpha negative beta the whole square. How do I have to get the value for this alpha negative beta the whole square? For that, let me consider the algebraic identity, that is a negative b the whole square equals to a square positive b square negative 2ab. Okay, now in this identity, what I'm going to do is I'm going to add 2ab. When I add 2ab to the right side, definitely the stuff on the right side cannot be equal to this left side. Actually, this is the expression, this is the expansion of this a negative b the whole square, but additionally I've taken positive 2ab. So to adjust this, I subtract 2ab. Now, so this positive 2ab, negative 2ab, it's a 0 plus, so it will cancel it. Still, the equation we have over here is true. That is the stuff we have on the left side, the stuff we have on the right side are equal. Here you may have a question, why do we have to add 2ab and subtract 2ab? There is a reason for that. Okay, let me continue this. So that is a negative b the whole square equals to a square positive b square. Now I'm going to combine this negative 2ab and negative 2ab. So then I'll be getting negative 4ab. I'll write this negative 4ab at last. First, let me write this positive 2ab over here. That is positive 2ab. Now we can combine this negative 2ab and negative 2ab. Then I'm getting negative 4ab. Actually, this is the square of a binomial a positive b the whole square. Let me write it. We get a negative b the whole square on the left side. And for this trinomial, a square positive b square positive 2ab, we can write the square of the binomial. That is a positive b the whole square. Then we can write this stuff as it is. That is negative 4ab. Okay, now we can replace this a by alpha and b by beta. Then we get alpha negative beta the whole square. The same thing we have to do on the right side. That is alpha positive beta the whole square negative 4 alpha beta. Okay, so why do I do all the stuff over here? Because my aim is to write this alpha negative beta whole square in terms of this alpha positive beta and alpha beta, so that I'll be able to use the values the negative 7 and 12. Okay, now I wrote this alpha negative beta whole square in terms of alpha positive beta and alpha beta. Now for this alpha positive beta, I can plug in this negative 7, or for this one directly we can plug in the 49, the value 49. And for this alpha beta, we know that the value is 12. Okay, let me plug in. So alpha negative beta the whole square equals to, so for this one already we got it, the value that is 49 negative 4 times the value of alpha times beta is 12. We can plug in 12 for this one. So then we get alpha negative beta the whole square equals to 49 negative 4 times 12 is 48. Then I'm getting alpha negative beta the whole square equals to 49 negative 48 is just 1. Okay, now I got the value of alpha positive beta the whole square already. It's 49. Now I got alpha negative beta the whole square. Its value is just 1. Okay, now in this equation, actually this is a required quadratic equation. In this required quadratic equation, we have to plug in the values for this alpha positive beta the whole square and alpha negative beta the whole square. Okay, now let me erase some stuff and continue the problem. Okay, now let me plug in the values for this alpha positive beta the whole square and alpha negative beta the whole square. Okay, let me continue. X square negative, and we know that the value of this one is 49, and the value of alpha negative beta the whole square is just 1 times x. Then we have positive, and for this one we have 49 times for this one we have 1 equals to 0. Then we get x square negative 49 positive 1 is 50. 50 times x, that is x square negative 50x. Positive 49 times 1 is 49 equals to 0. So this is the quadratic equation which has two roots, alpha positive beta the whole square and alpha negative beta the whole square.